Okay, so we are in 6.9 jumpstart problem. And it's basically asking us to graph these functions relatively quickly. And so this is what I did for number one. And it's a lot of like writing, but when they say a quick graph, they're relying on the fact that you know what each of these numbers do. Okay, so I'm gonna write. I'm gonna erase this because this was my notes from earlier. I'm gonna write out what each number kind of does to it, and then hopefully that you guys are all okay with it. Okay, so this guy here, this is called my midline. So plus 2 means up 2 from your x-axis. So that's gonna be this guy. You're gonna have like a midline here. Okay, so imagine your function goes a little bit above this and a little bit below this. Okay. Okay, the next number that I look at is this pink number, right? And this number is called my amplitude. So an amplitude is that's how high and how low it goes from the midline. Okay. So I'm going to take my 2 here. So this is my midline. And then I'm going to add 2 and subtract 2. And that's the highest and the lowest it could go. So this is the highest and lowest the function goes. So if you wanted to think about it, that's kind of where the range is. The range is living anywhere from 2 minus 2, which is 0, all the way to 2 plus 2, which is 4. Okay. So if you can kind of think about like this being like, I don't know, a railroad track if you want, that it's only going to live between that railroad track. Do you kind of see how it's like it looks like a road, right? Where the top is the left curb and the bottom is the right curb. And the middle is like that. It's like you can't cross it over because you're going to go into oncoming traffic. Does that make sense? Okay. So the last thing that we want to talk about is this. Let's make him. Oh, I should have made him pink. Sorry, I want to go with pink now. My road needs to be pink because I forgot I was using that as a color. So it goes between here and here. Okay. So this guy here, this is called your speed. And we technically call him our angular speed. So if you think about what speed is, like how fast you go in a car, it's like, I don't know, 40 miles per hour. So what it means is how far you can travel in one unit. So because this is angular speed, we're talking about how far it can travel over a radian or a degree or a second, right? So this one is 30 degrees per second. So this means, like, if you remember Carlos and the Ferris wheel, he was able to travel 30 degrees over 1 second of time. So angular speed is 30 degrees. So I'm going to take this over here. And how this helps me is I think about this, okay? This helps me think about if I can travel 30 degrees in 1 second, my question is, how long will it take me to go around the whole circle? Of 360 degrees, right? So like there's this proportion thing that's happening. So you're like, well, if 30 seconds, 30 degrees in 1 second, how much is it going to be for 360 degrees? And some of you see this proportion happening right now, and you're like, well, to 30 times what gives me 360? And you're like, oh, that's times 12. So that would be 12 seconds. So it would take me 12 seconds. Oops, that's not 12. 12 seconds. Right? Does that make sense? That's Seco. We're going to go with 12 seconds. Okay. So what does that mean? It means from here all the way to here is one period or one cycle. So it's like a Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. That's one cycle of a week. Okay, now you're thinking, okay, Miss Johnson, I get it. But how do we actually graph this? So from here, you're either going to remember that sine looks like an S, so it looks like this, where I pay attention to the points middle, high, middle, low, middle, or you will plug in numbers based on this 12-second interval here for you to find that. And I'm going to do both right now just so that it makes sense. Oh, that's a question mark. Sorry, this is not so neat. This is a question mark, like what number can go under here, right? So the answer was 12. It takes me 12 seconds to finish the whole thing. Okay. So let's pretend that you didn't know that this was middle, high, middle, low, middle. Let's pretend you didn't know what the sine function looked like. So what I'm going to do is I'm going to start at 0 and I'm going to plug it in. Okay, so I plug in 0 into this whole thing. And some of you are like thinking, Miss Johnson, should I be using Desmos? Yes. Because this is degrees right here, that means you need to hit settings and hit degrees. Okay. And yes, we could just graph this out, but I'm not going to, just so that we can practice this. All right, so let's go to sine of 30 times 0 plus 2. And the answer is 2. So this point here is this point here, which makes sense. It's on the middle. Okay. If you continue this out, that means that this point here at the end will also be in the middle. What x value will this be? What x value will this be right here? No, at the end. So this is 0, this is the beginning, and it's going to take some time. What's the last x value? What's this x value going to be? It has to do with how long it takes. How long does it take to complete a whole cycle? Yeah, 12. 12, right? Okay, so that means I'm going to plug in 12 here instead of this 0. And it also comes out 2. That's not a surprise because this thing told me, right? So at 12, it's 2. This is literally how I graph every single one. Okay, then how do I find this guy right here? I want to graph this guy right here. What's this guy going to be then? What would you guess this guy to be? Yeah, it's 6. Why does it make sense to be 6? Yeah, it's half. It's halfway in between. So this is when Carlos is halfway all the way around the Ferris wheel. All right. So now I have my middle, middle, middle. Now what I want to do is I want to figure out when it's at its highest. So what do you think this one would be? Let me change colors just so you guys can. When do you think that one would be? When do you think that one would be? Yeah. Why would it be 3? Yeah, because it's half of the half, right? Or it's a fourth of the 12th, right? So we're just going to go with halves here. So at 3, it's 4. At 3, my output is 4. So I'm going to do that. Do you guys already see the sine curve coming in? Okay, then what would this one be? What would this one be right here? Yeah, 9. And it's at 0. Is it supposed to be at 0, Miss Johnson? Yes. Because remember, it's supposed to go as high as 2 plus 2 and as low as 2 minus 2. Everybody good? And then you can repeat it, right? So if you notice, it goes 0, 3, 6, 9, 12. Well, what would the next one be? What would the next interval be? Yeah, 15. And where would he go? High, middle, low. High, middle, or low? Yeah, it'd be high. Like 4 high? Yes, 4. Because remember, that's where he's living. And then you can continue going this way or you can go this way. It doesn't really matter. But you should kind of see this pattern here. Does that make sense? So you should be able to, on our tests, right? You should be able to, number one, describe what everything is and that how it affects the graph, right? Describe everything and then how it affects the graph. So then you're going to come in here and try to draw a nice curve, which Miss Johnson is somewhat challenged in drawing nice curves, right? Yeah, there you go. So it's supposed to look like a curve, and then you can kind of like let this guy go continue this way, and then let this guy continue this way, right? So yeah, that was bad. See how Miss Johnson does not know how to continue that curve. All right. So if you are using a graphing calculator, right, which we were, now you can actually graph this and just put X instead. And then there's your curve. And if you kind of look at it, it looks like what we got, right? Like look at that and look at that. Looks the same. Goes as high as 4, goes as low as 0. At 0, it's at 2. See right there? And then it goes high, and it goes low, right? All right. Hopefully this makes sense in terms of graphing things. If you're graphing, so Ms. Johnson, this is the sine curve, right? Middle, high, middle, low, middle, right? This is the sine curve because it looks like a S to me, right? Cosine's curve looks similar except it's a V. Cosine is high, middle, low, middle, high. And then it looks like this, right? And then it continues, right? So cosine looks like a V to me or a C. If you look sideways, it looks like a C. And then this is an SS. Okay. All right.